Welcome children to the virtual chemistry class. In the last video we have started the lesson 2 for your half-yearly syllabus, and the theme of this chapter is just elements, compounds and mixtures. In the previous class I have already introduced pure substances, element, compound, mixtures, and we have learned about the arrangement of 118 elements, which is typically termed as periodic table. We have learned that metals and non-metals, different states of metals in the room temperature. Today we'll discuss about symbols of elements. So before we go to discuss about symbols of elements, let us start today's class with an activity. This is described in your book. The aim of this activity is to identify the different elements, and for this activity petri dishes with iron powder, sulfur powder and zinc granules are required. Now this iron powder, sulfur powder, iron powder means this is the dust of iron metal, sulfur is the non-metal and zinc is a metal. It is silvery white. It is also silvery white if there is no rust is present, and if rust is present then it will be looks like a pale brown. Sulfur is yellow in nature. Observe the samples of different elements and identify them. Classify elements into metals and non-metals on the basis of their appearance. Since iron powder and zinc granules are shiny in appearance, so iron powder and zinc granules are metal. Sulfur powder are dull in nature, that's why it is a non-metal. So we have classified these three as per their appearance. Today we'll learn about symbols of the elements. Now symbol, it is an abbreviation or short representations of an element. For example, iron powder. The short representations of iron powder is Fe. The short representations of sulfur powder is S. The short representations of zinc granules is Zn. The symbols of every element is usually derived from its English or Latin name. Some elements are denoted by the first letter of their name in capital letters. For example, hydrogen. The name starts with H and the symbol is H for hydrogen. Oxygen. As the name starts with O, so the short representations or abbreviation or symbol of oxygen is O. Similarly, nitrogen starts with N, so the symbol is N. Fluorine starts with F, so the symbol of fluorine is F. Phosphorus starts with P. The symbol, short representations or abbreviations of phosphorus is P. There are certain elements having the same first letter. For example, carbon, calcium and cobalt. The first letter for all these three is C. Now such elements are represented by two letters. The first letter is written in capitals and second letter is written in small. Now the symbol of carbon is C and symbol of calcium, first and second letter Ca. First is in cap and second letter is in small letter. Cobalt, Co. First it is in the capital and second it is in the small. There are certain elements whose symbols are derived from their Latin names. For example, sodium, the Latin name is natrium, and thus the symbol of sodium is Na. Potassium, the Latin name is kalium, and the symbol is K. Latin name of iron is ferrum, and thus the symbol of iron is Fe. So first 20 elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, and the symbol hydrogen H, first letter, helium He, first and second, lithium Li, first and second, beryllium Be, first second, boron only the first letter B, carbon C, first letter, nitrogen N, first letter, oxygen O, first, fluorine F, first letter, neon Ne, first and second, sodium, that comes from the Latin name Na, magnesium Mg, aluminium Al, first and second, silicon Si, first and second, phosphorus, the first one, sulfur S, the first letter is used for their abbreviation, chlorine, first and third, it is important, this is not first and second, the first and third, Cl for the case of chlorine, argon Ar, first and second, potassium kalium, this is K, from derived from the Latin name calcium Ca, first and second. There is another activity to study the symbols of the elements in the periodic table. We have completed this activity in the first video named elements. Next is the molecules of elements. Now a molecule is the smallest particle of a substance that can exist independently. This term is very important, independently. A molecule can exist independently, but an atom can't exist independently. A molecule of an element is made up of same type of atoms for an element, but this is not true for the case of the compound. For the case of the compound, the molecule is made up of different types of atoms. However, first we'll learn the molecules of an element. Since we know that the element contains only one kind of atoms, one kind of species, and thus the molecule of an element is made up of same type of atoms. Look at this figure 2.3, hydrogen molecule. Imagine or visualize that these white balls, or dumbbell shaped white one, is just an hydrogen atom. So when two hydrogen atom, the dumbbell shaped hydrogen atoms, when combined with another hydrogen atoms, it will form an hydrogen molecule. So the formula of hydrogen molecule is H2. Why? Because one hydrogen, another hydrogen, H2. Two oxygen atom, this red ball, O2, like this. This is given alongside the balls and the stick model of some molecules of element. The second element is oxygen, two balls. This is just the model. This is the molecules, the molecular models of molecule. Oxygen, these are attached with two hands. This is the bond, chemical bond. Nitrogen molecule, this blue colored ball is nitrogen. Imagine or visualize that this is a nitrogen atom. When two nitrogen atom combine with three chemical bonds, look at this 1, 2 and 3 chemical bonds, it will form N2. So the molecules of nitrogen is N2. Look at this sulfur molecule, 1, 2, 3, 4, 5, 6, 7, 8. So the molecule of sulfur is S8. As elements are represented by using symbols, what we have learned, molecules are represented by chemical formula. So the short representations or abbreviations of an element is known as symbol, and the representation, the short or symbolic representations of molecule is known as chemical formula. This is the definitions. A chemical formula is a symbolic representations of the number of atoms that constitute a particular molecule of an atom, of an element. For example, one molecule of hydrogen elements contain two atoms of hydrogen, so its formula is H2. Look at this. The ball and stick models of hydrogen, one hydrogen atom represented as one ball, another hydrogen atom represented as another ball. There is a chemical bond between two hydrogen atoms. So two hydrogen atoms combine to form one hydrogen molecule, and thus the chemical formula of hydrogen molecule is H2. You can say the chemical formula of oxygen molecule is O2. Remember, it is H2 or O2. That should be this 2, 3, 4, 8. That should be subscripted, not to be written alongside with H. Note that 2H is different from H2. Look at this H2. This 2 represents that two hydrogen atoms combine to form one molecule. So that means H2 represents only one molecules of hydrogen, while 2H represents two atoms of hydrogens. So if two atoms of hydrogens forms a chemical bonds, this is the chemical bonds as per your ball and stick models. If they forms a chemical bond, they combine with a chemical bond, then it will form H2. H2, that 2 is subscripted, and this is the representations of one molecules of hydrogen, while 2H is the representations of two atoms of hydrogen. Molecules that contain only one atom will be termed as monoatomic. Mono means one. For example, sodium, potassium, helium, neon, argon, krypton, xenon, these are the monoatomic in nature. If the molecules that contains two atoms, then it will be termed as diatomic. Two atoms are present. Hydrogen, oxygen, nitrogen, they are the diatomic. Molecules that contains three atoms are said to be triatomic. Tri means three. For example, ozone, O3. Molecules that contains four or more atoms are said to be polyatomic. For example, sulfur and phosphorus. The chemical formula of sulfur is S8. We have discussed about this S8. 1, 2, 3, 4, 5, 6, 7 and 8. Look at this figure. 8 sulfur atoms are joined together. Their chemical formula and number of atoms are present. Hydrogen 2 atoms, H2. So this is diatomic. Oxygen 2 diatomic. Iodine I2 diatomic. Nitrogen, fluorine, chlorine, bromine, these are all the diatomic molecules. While ozone O3, the number of atoms in one atom in a molecules 3. So ozone is a triatomic. Phosphorus P4. So 4 atoms present in one molecules of phosphorus. Sulfur S8, that means 8 atoms of sulfur are present in the one molecule of sulfur. So phosphorus and sulfur are the polyatomic, while ozone is triatomic. Bromine is bromine, chlorine, fluorine, nitrogen, iodine, oxygen and hydrogen are the diatomic in nature. So what we have learned today, we have started with this activity to identify different elements, and there is an activity. Then we have started symbols. These are the rules for writing the symbols, and there are certain other rules. First letter, third letter, we have learned this, and the important Latin names of different elements. Then we have learned about molecules, chemical bond, the ball stick model of some molecules, the definitions of chemical formula, monoatomic, diatomic, triatomic and polyatomic. And this table is very important, table 2.2. It is very important. This table represents the different elements and how many atoms are present in a particular molecules? Okay children,